All right, ladies and gentlemen, so day 2, exponents. We're converting fractional exponents into radicals. Yesterday we talked about all of our exponent rules. Today we're going to talk about exponents to radicals. So first and foremost, take a second, fill out that table, the first part of your notes. Once you've done that, you can go ahead and check your answers with mine and see if we see a pattern. Perfect. So since you paused it and now you're checking your answers, check and see, does your table match mine? Right? We should notice a pattern here. If you look at the rows, we get equal numbers as we go across the rows. What happens is that we'll see fractional exponents actually turn into radicals, and radicals turn into fractional exponents. So we should get the same exact thing. They mean the exact same thing. So when you notice what your answers to the problems in the same rows, they're the same. Right? If you didn't get the same answers, go back, try them again. If there's some pattern that relates to two expressions in each row to another, yeah. We're going to notice 1/2 is the same as a square root. 1/3 is a cube root. We'll talk about that in a second. So like I said, please make sure your numbers match up. And we should have seen some sort of pattern happening there. So our basic conversion, the first thing, it should be a really quick day of notes. First thing, basic conversion, a to the 1 over n power is the same as the nth root of a. So anything like 4 to the 1/2 power is the square root of 4, or the second root of 4. 4 to the 1/3 power is the same as the third root, or the cube root of 4. 4 to the 1/4 power is the fourth root of 4. So anything to the 1 over n power is that nth root of our number or our variable. Pretty simple. So if we look at simplifying some of these without a calculator, notice it says simplify. So first thing we're going to do is we're going to change them to radicals, and then we're going to simplify. 9 to the 1/2 power. What happens is it becomes the square root of 9, right? This 2 down here determines what root it's going to be. Well, we all know the square root of 9 is 3. 25 to 1/2 power, same thing. This 2 determines the root. It's the second root of 25, or the square root of 25. Well, we all know the square root of 25 is 5. Same thing, we keep going. 27 to the 1/3 power, we get the third root of 27, or the cube root of 27. Now, if you don't know that in your head, right, it is 3. You can think of what to the third power equals 27. Ends up being 3. Now, when we are using our calculators, there's an actual really cool button. If you hit math, and then a fifth one down should be an x root, square root sign. You can plug any root you want in there. In this case, it would be the third root. But right now, we're doing it without a calculator. So, the fifth root of 32, right? Our denominator is telling me what my root is going to be. Well, what to the fifth power equals 32? Ends up being 2. Alright, so you should be able to solve some of these without your calculator just by translating them into different radicals. Now, a little more complicated. If our numerator is not a 1, if it's an a, if it's a different number, what's going to happen is n to the a over b power, otherwise written as n to the a over b power, is the same as the b root of n to the a power. Our numerator is going to become our power. Our denominator is still becoming our root. So we should be able to change any fractional exponent, otherwise known as a rational exponent, into a radical. And actually on Monday we're going to see the opposite. We're going to change our radicals into fractional exponents. So, numerator becomes the power. Root becomes our square root. Now, there is another way to write it. You don't need to write it with the power underneath the radical. You could also write it as the b root of n, get rid of that, all in parentheses to the a power. Either one of these works, and we're going to see this way is actually a little bit easier with some of the problems. Most of the time I'll do it this way, but sometimes it's easier that way. So, let's practice it. First one, 9 to the 3/2 power. So, I'm going to make a radical. Right? My 2, my denominator, becomes my root. So it's the second root of 9 cubed. Okay? Now, like I said, I may write it a different way. It might be a little bit easier for some of these problems. I might write it as the second root of 9 all to the third power. These two things mean the same. This top one's a little bit easier to do though. Right? The square root of 9 we know is 3. And then 3 cubed is 27. And if you do it this way, you should get the square root of 729, which also equals 27. So either way should work for you. Just this way might be a little bit easier to do if you don't want to use your calculator. If you want to use your calculator, go ahead and do it the first way here, on the bottom. Alright, the next one. 8 to the 2/3 power, same thing. My denominator becomes my root. 8 goes underneath, and you can either put the squared inside, or you could write it cube root of 8 squared. Now I'm just going to leave it as the top one. I'm going to erase this bottom one. You can do the bottom one if you'd like, but you don't have to. So 8 squared will give me 64. So the cube root of 64, well, what to the 3rd power equals 64? It's going to be 4. Our third one, 64 to the 5/6. This one, we're going to take the 6th root of 64, and we're going to raise it to the 5th power. Like I said, it doesn't matter how you write it. I'm going to write it this way because it's a little bit easier to do without a calculator like that. So the 6th root of 64, well, what to the 6th power gets me 64? I know that's 2. So 2 to the 5th power is going to be 32. And that's my answer. Alright, so you can write it a couple different ways. Sometimes it's beneficial to write it one way over the other. Alright. 3 more, we're done. 125 to the 2/3 power. So, cube root 125, all of it squared. Right? I'm going to write it that second way I taught you. So, cube root of 125. What to the 3rd power is 125? That would be 5 squared. Well, that's going to equal 25. Next one, 121 to the -1/2 power. First thing you need to do, just like we talked about on Thursday, is we need to make this a positive exponent. We can't deal with negative exponents. So 1 over 121 to the 1/2 power. Then I can change this into a radical. 1 over the 2nd root of 121. My denominator becomes my root. 1 becomes my power, but I don't have to put the 1 there. Well, the square root of 121 is 11. So my answer is 1 over 11. Pretty easy. Alright, the last one. Last one's a little tricky one. I have 1/32 to the 1/5 power. So my denominator becomes my root. 1/32 underneath it. Now, we didn't show you this rule. We're actually going to learn this rule a little bit later in the unit. But what you can do is you can take that 5th root and give it to the 1, and take the 5th root and give it to the 32. Or you can punch this first part into your calculator. Either way works. So the 5th root of 1 comes out to be 1. The 5th root of 32 comes out to be 2. So our final answer ends up being 1/2. Now, if I was you, I would make sure I wrote down this extra little part that I wrote here. Right? The b root of n, and in parentheses, all raised to the a power. Because you can write it either of these two ways. Alright, now that you're done with that, all your notes should be taken care of for the day. Do your homework, and have a great weekend.